Good evening.
Good evening, waiting for others. And just let me know when all have joined.
Yes, sir.
All right. Have everyone joined? Shall we start?
Yes, sir.
Okay, so we had to do the NCERT exercises related to binomial expansion. And I think you were in the exercise 8.2, right?
Yes, sir.
Can you tell me the question number?
First one.
First one. Okay. So is that question this? Because I need to, okay, 1 minute. Just pop it out.
Hello.
Hello.
Hello, Adarsh, this is Raghav.
Oh, hello. Good evening, sir.
Yeah, good evening. So it is actually not binomial expansion, it is the arithmetic progression. So I've completed till geometric progression and I've explained till arithmetic mean. So
Okay,
if
sir.
you can, yeah, if you can explain the geometric
I
mean.
got the message of exercise
Yeah,
8.2.
yeah, 8.2. Actually, 8.2, it's the geometric progression problems that they have to do. So they need to know what is geometric mean and the relation between AM and GM, and then to proceed with the problems. Okay.
Okay, sir.
Okay.
Okay,
Yeah,
sir.
yeah. Thank you. Students,
Yes, sir.
yeah, are you all there? Like I mentioned yesterday, make the class more interactive. Like when sir is asking, please respond back. Okay.
Yes, sir.
Is that clear? Yes. So please carry on.
Okay, sir.
Yeah. Thank you.
All right. So we had to do this geometric progressions, right? So just to give a brief detail about the geometric progression, you must have studied about the arithmetic progressions earlier in class 10th, right?
Yes, sir.
Yes, sir. What is arithmetic progression? Arithmetic progressions in AP, the series used to be have a common difference, right? Like if I write something 1, then the next number would be 4, then the next number would be 7, then it is 10, then 13, then 16. If I go on this, so what do you find in this? You find a common difference, D, right?
Yes.
In every number, there used to be a common difference. But in geometric progression, we have a common multiple. So it will be like 1, then 2, then 4, then 8, then 16, then 32, and so on. So you'll be finding a common multiple, common like some common ratio is there that has been multiplied with every number, so that to get the next number, right? That is 2 here in this case. Do you agree?
Yes, sir.
Yes, sir.
Right? So for example, if I say that a geometric progression, a GP, a geometric progression or geometric sequence is a sequence in which each term is varied by another by a common ratio, that is R. All right. So I can write the numbers as GP. I can write a general GP as the first term A, then A into R, then A into R square, then A into R cube, and so on. So earlier what used to be there? N plus 1 minus n, right? That used to be constant. Agree?
Yes, sir.
For example, 5th term minus 4th term, 6th term minus 5th term, like that. So 5th term minus 4th term is equals to 6th minus 5th, and so on, right? Because there we used to have a common difference. Agree? But here we have a common ratio. N plus 1 by n is equals to n plus 2 by n plus 1, like that, and it goes on. For example, A into R by A, this term by this term. That is equals to this term by this term. AR square by AR. That is equals to this term by this term. Is equals to AR cube by AR square. And in all of the cases, you have the number R, right?
Yes, sir.
So this is called a geometric progression. Write it down. We'll be moving on to the next page. This is called a GP, geometric progression. And let me know when it is done.
Sir, finish.
Done?
Yes, sir.
Yes, sir.
Good. Everyone, shall we move on?
Yes, sir.
All
Yes,
right.
sir.
All right. Next topic. So now we'll be seeing some properties of GP. These properties helps us to solve problems. Properties of GP, right? So first one, okay. Three non-zero terms are in GP if and only if, you know, this is written as IFF, if and only if B square is equals to AC, that the product of the first and the last term is equals to the sum of is equals to the square of the middle term. If you have been given three numbers, okay, you have been given three numbers, and they are asking that you have to check whether you have to do it like this, whether they are in GP or not. So you'll be doing like this, checking like this. The product of first and last term will be equal to the square of this middle term, right? Next term, next one. In a GP, three consecutive numbers can be first focus here, then you write, can be taken as A by R, A into R. You just have to consider that the common ratio should be same, right? Similarly, four consecutive numbers, if I'm talking about four consecutive numbers, can be written as A by R square, A by R, A into R, like that. Are you getting it?
Yes, sir.
Or in a better way, you write it like this: A by R cube, A by R, A into R, AR cube, to make it symmetrical. What is the common ratio here? Tell me. What is the common ratio here?
R.
No. Divide the next term with the final previous term. Then tell me. It's very easy. Divide the next term with the previous term. What you are getting? Okay, see here. If I divide this by this, AR cube divided by AR, what am I getting? R square.
R square.
If I divide this by this, yeah, exactly. AR divided by A by R, you'll get R square. If I divide this by this, so A by R divided by A by R cube, it will be R cube upon R. That will be R square. In all the cases, I'm getting R square. That is my common ratio, isn't it?
Yes, sir.
Got it? Write it down. The minute is done.
Done, sir.
Done. Okay, shall we move on? All
Yes,
right.
sir.
So if I just write to 5 numbers in AP, then sorry, GP, then it will be, to make it symmetric, I'll be writing at A by R square, A by R, A into R, A into R square. Just to make it symmetric. Okay. Next, in a finite GP, the product of the terms, equidistant from the beginning, and the end is same. For example, we have infinite series T1, T2, T3, T4 are the numbers, and so on. Tn minus 3, Tn minus 2, Tn minus 1, Tn, like that. N numbers are there, infinite. Okay. So what does it say is that if we take a number, let us say the third number from the beginning and the third number from the end. For a second, third number is this. This is the third number from the end. This is the third number from the beginning. And we multiply that, Tn minus 2. And if we take another number, let us say second number from the beginning and second number from the end, T2 into Tn minus 1, both will be same. Okay. The first number from the beginning, first number from the end is equal to T1 into Tn. Any number you take, the same position should be there from the beginning and the same position should be there from the end. So that product will be same. Agree? Any doubt there?
No, sir.
Good. If each term of a GP is multiplied or divided, right, by a non-zero number, by a non-zero constant, then the resulting sequence Resulting sequence is also a GP. Is also a GP with the same common ratio. With the same common ratio. Okay. So if you take any number A1, AR square, AR cube, AR to the power 4, and so on. Okay. If you have taken a GP like this, and each number you have divided with a certain constant K, each number is divided by a certain constant K, let us say. Okay. So resulting sequence will also be a GP. Why? Because if you take this number and divide it with the previous number, this number will be cancelled. Because you have taken every number, you have included that number in every term of the sequence, isn't it? So that number will be cancelled. So ultimately our common ratio will be same. It won't be affected. Yes or no?
Yes, sir.
Right? This term
Yes,
will be
sir.
same. Write this page. We'll move on to the next one. Tell me when it is done. Is it done?
Yes, sir.
Everyone, shall I change the page?
Yes, sir.
Okay. All right. So next thing, we did this one. Okay. Next point says that the product and quotient product and quotient of two GPs is also a GP. If I multiply two different GPs or if I divide two different GPs, whatever I'll get again will be a GP. If each term of a GP is raised to the power by the same non-zero number, the resultant sequence is also GP. The resultant sequence is also a GP. All right. And the last one, if A1, A2, A3, and so on is a GP of positive terms, then taking log of A1, log of A2, log of A3, and so on is an AP. Because that common difference is there. Okay, I'll tell you how. See, let us say that I have and vice versa. See, if I take a sequence AR square, AR cube, and so on, right? So if I take log of them, log A, log AR, log AR square, log AR cube. Can you write this log value as log of A plus log of R? You know the properties of log? Do you know the properties of log? Ananya, Ashwin, Chitesh,
No, sir.
Tanushree? No? So basically the thing is that, okay, I'll tell you how. Okay. Earlier it used to be in class 10 chapter, but then it got removed. Log of A into B is nothing but log of A plus log of B. And another thing, log of A to the power B is that B comes outside the log, B log A. These two are the properties that you require right now to understand this statement. So it is, if I'm writing log A, so it is log A. Can I write log AR as? Can I write it as log A plus log R? Everyone, tell me yes or no.
Yes, sir.
Right? And then can I write log AR square as log A plus log R square? And instead of log R square, I can write 2 in front of it, 2 log R. Yes or no? Say yes or no, everyone.
Yes, sir.
Right? This log R square, this 2 came forward with the second description that I gave you. Now, this is first term, this is second term, this is third term, and that will be going on. Okay. Now tell me, what is the difference of second term and first term? Anybody? What is 2 minus 1? Tell me. What is 2 minus 1?
R.
Log R. What is 3 minus 2?
Log R.
Log R. And it will go on. The fourth term will be log A plus 3 log R. You can check it out. So what is then 4 minus 3? Again, it will be log R. So is it a GP or AP? When we have common difference, it becomes AP now.
Yes, sir.
So whenever you take the log of any GP, it becomes AP like this, hence proved. Agree?
Yes, sir.
Write it down. And all the properties are over. Now we'll be moving on to the formulas. These are important because these helps to solve different questions, to iterate the questions, make it easy in solving like that. Nothing to memorize, try to understand everything. If you are not able to understand any part of it, just ask me, I'll explain to you n times. Write it down fastly.
Completed, sir.
Completed, everyone? Everyone tell me.
Yes, sir.
Pardon?
I said yes, sir.
Okay. All right. So, okay, this is also you have to write. And then let us go on to the general formulas of the geometric progression. Write it down. This is the explanation part of the last point. Done? Is it done?
Yes, sir.
Yes, sir.
All right. All right. So now we'll see some general formulas of geometric progression. So first one is, let us say that we have a general progression. I'll be considering a general progression like this: AR square, AR cube, and so on, right? AR n minus 1, AR n. So A is called the first term. A is called the first term. R. How we calculate R? Dividing the next term with the previous term. R is the common ratio. Common ratio, right? Then is the nth term. Sorry, n minus 1 is the nth term. Because A is the first term in that case. Right? If you want to find the fifth term, so it will be AR to the power n minus 1. Why this? AR4 will be the fifth term. Always remember, it is not AR5. Okay, because they are starting with A. So this is the first term. And this will be the second term. A to the power R to the power 1 is there. So that will be the second term. R square is the third term. So that's why always AR to the power n minus 1 is the nth term. Understood?
Yes, sir.
All right. Next, second, how do we calculate the common ratio? Common ratio. Common ratio is calculated as any term. We can take any term and divide it with the previous term. Previous term. All right. This is how we calculate the common ratio, or we can write it at Tnth by Tn minus 1. Or I can say is like AR to the power n minus 1 by AR to the power n minus 1, and the number prior to this is minus 1. That is AR to the power n minus 1 by AR to the power n minus 2. So it will be A cancelled, R to the power n minus 1 plus n minus 2. Sorry, minus. Minus of n minus 2. So it will be R to the power minus 1 plus 2, or just R. This is the common ratio. Write it down. Understood till here?
Yes, sir.
Yes, sir.
It will be T2 by T1. Can be written as T3 by T2, whatever.
Done, sir.
Everyone done?
Yes, sir.
All right. Okay. The third point, sum of n terms. Right? Sum of n terms of GP. This is what you have to calculate. The sum of n terms is A plus AR square plus AR cube and so on. Right? The sum of n term is directly given as A Rn minus 1 by R minus 1. R is common ratio, A is the first term, N is the sum of n term that you need to calculate. Here condition is that R should not be equals to 1 and R should be greater than 1. These two conditions should satisfy. Then only you can apply this formula. And Sn is equals to n times A if R is equals to 1. This is the sum for finite terms. For finite terms, if you know the number of terms. There is a condition called for infinite terms also. Infinite terms. Sn is equals to A by 1 minus R. If the number of terms are infinite, you're not able to calculate that, how many terms are there. So the sum in that case will be A by 1 minus R. Again, the condition R should not be equals to 1. Just let me know when it is done.
This was the basic theory about the GP. Let us solve some questions after this.
Let me know when it's done.
Done, sir.
Everyone?
Yes, sir.
All right. So let us solve some questions. Okay. Question says that find the sum of first 5 terms of GP 10, 30, 90, and so on. This is a GP. We have to find the sum of first 5 terms. Try to solve this.
Sir,
Yeah. What answer did you get? How much? What did he get as the answer? Could not hear that. Are you saying something, Vanda?
no. Sir, the common difference is not same. I mean,
Exactly, because
ratio.
this is not AP. That's what I'm saying. This is not AP, this is GP.
No,
Okay,
sir.
I'm sorry. First one.
Okay.
Okay. What you're saying?
The common ratio is not same.
Even that is not same. How? Did you divide 30 by 10? Is it not equal to 90 by 30? Is
Oh,
it not
sorry.
equal to 3?
Thought it was 40.
No, sorry. It's 90. 90. Now solve it.
Okay, sir.
Taking too much of time. It's easy. See here.
1205.
120.
5.
A little bit mistake. Little bit. Very little. So Sn is equals to. Who said that? Ananya. Who answered this?
Sir, I'm not getting his answer.
Sir, 1210, sir.
1210 is the correct answer. That is the correct answer. See here, everyone. The first term is 10. A is 10, right? What is common ratio? Common ratio, we just have calculated, that is 3. And
Three.
that term that we need to find, that I told for the first 5 terms, and minus 1 divided by 3 minus 1, right? It is very easy. 10 into 3 to the power 5. What is 3 to the power 5? 3, 3, 9, 3, 27, 3, 81, 3, 243. Minus 1 by 2. So that is 10 into 242 by 2. That is 10 into 121 or 1210. That's it. What was there to take so much of time? Isn't it?
Yes, sir.
Write it down, everyone. Shall we move on to the next page? Everyone done?
Yes, sir.
Yes, sir.
All right. So next question says that find the find the 10th term and sum of first 7 terms of GP, that is 2, 4, 8, and so on. Let us solve this.
Sir.
I'm sorry. Yeah. What did you get?
Sir, 10th term is 1024.
1024. 1 minute, 1 minute. Where did that page go? 10th term is 1024. Yeah, that's correct. And the sum of 7 terms?
254, sir.
254. That I need to calculate because this I've given the question from myself only. See, so 10 term will be a r to the power n minus 1 is the nth term, right? So a is 2, r is 2.
Sir, it is 254.
Okay, I think then that's correct. So 2 into 10, 2 to the power 9, it will be 2 to the power 10 only. So 1024 is correct. Okay. Sum of n terms, sum of 7 terms is equals to a r to the power n minus 1 by r minus 1. I'm writing the formula again so that you remember it. A is 2, r is 2, 7 minus 1 by 2 minus 1. It will be 2 into 2 to the power 7 minus 1. So that will be 2 to the power 7 is how much?
127.
128 minus 1, right?
Yes.
254. That's correct. Good. So you understood how to solve these questions about GP?
Yes, sir.
Only these much formulas are there. Something you'll have to like questions will be there. Different kinds of questions will be there that will be relating the properties of geometric progressions also. All right. So you have to relate with them. You'll have to solve more questions, and then if I get the next class, I'll be or sir will take the next class most probably. So he'll be including those questions, and you should also solve by yourself, right?
Yes, sir.
Any doubt as of now?
No, sir.
Anyone? Sweta, Sanjana, Ritika? I did not hear anything
No,
from you
sir.
today.
No,
Yes,
sir.
sir.
All right. You like the session?
Yes, sir.
Okay then. If you don't have any doubt, shall we keep it for today?
Yes, sir.
No doubt, sir.
Okay, okay. All right, all right. Okay then. Bye for today.
Thank you, sir.
Thank you, sir.
Thank-
Thank you, sir. Thank you, sir.
Thank you. All the best.
Thank you, sir.
All right.